It's late at night and I am ready for bed, but I gotta get this dilation stuff on. So, let's kick it out. All right, we're performing dilations on points on a graph, and we'll also be determining scale factors. So, la-di-da, and all with the eye of Sauron just glazing right at you the entire time. All right, here we go. A dilation is a proportional enlargement or reduction of a figure through a point called the center of dilation. Alright, so that means you've got something like this, and it can enlarge its shape or contract. And that's kind of why I have the eye here, because an eye, when you shine a light into it really bright, it can just go, right? I think it shrinks. Maybe not. When you shine a light into it, maybe it opens up. I can't remember, but one of the two. The size of the enlargement or reduction is called the scale factor. So maybe if it's by 2, that means it enlarged. It doubled in size. All right. Notice enlargements are when they're above 1. So like 2 means it doubled in size. A 3 means it tripled in size. A 10 means it tensied in size. And then reduction is somewhere between 0 and 1. Guys, we've dealt with this before when we're dealing with exponential equations and growth and decay. Once again, if you have half of something, it's going to shrink it in half. Okay, so rule for dilation is to dilate an image, you multiply the scale factor by both your x and your y. So you need to multiply both x and y coordinates. Alright, so we're going to nail out a few of these. Okay, so first of all, here's the original image. It says use a scale factor of 2 to complete the table. Alright, so it says I got to multiply 2, right? So times by 2, everything gets multiplied by 2. So what is negative 2 times 2? I believe that's negative 2 times 2. I believe that is negative 4. Okay. And then what is a negative 3 times 2? I believe that's negative 6. All right, so it says actually graph both original and new triangles. So I'm going to go negative 2 and negative 3 is located roughly here. Okay, that's A. Let's see if I can do this. Alright, that's A. And then the new point is negative 4, negative 6, right down here. Okay, and we're going to call that A prime, like Optimus. That's what that little hyphen up there, or apostrophe, it means prime. Alright, so that's A prime. Okay, next, let's do this in red here. Alright, I'm going to take negative 4 times 2, negative 4 times 2. That's going to be negative 8, I believe. This might go off the graph slightly. Woo, this will be fun. Negative 8. And then I'm going to take 0 and multiply 0 by 2. Oh man, this is horrible. Oh. Alright, 0 times 2 is still 0. So B, original B is at negative 4 and 0. So that's right there. That's original B. Alright. And then B sub prime is going to be negative 8. It's going to be right around there. And that's B prime. Actually kind of sounded like Optimus. I am Optimus Prime. No, that didn't sound like it at all. That was horrible. Alright, now I'm going to multiply this 0 times 2. And 0 times 2 is 0. You guys get the feeling of this? And 1 times 2 is 2. So the original C is located at 0, 1, which is up there. So that is my C, baby. Oops, that's C. I don't know what I was doing. My other one's located at 0, 2, which is up here, and this is going to be C sub prime. C prime. Alright, I kind of feel like prime quarter house now. Ooh, that's good. Get some of them butter bread. The butter bread with garlic salt. Oof. Alright. I am going to now connect the dots here. I'm going to take all my originals. So C, B, A. And I'm going to connect those. That's a large triangle. But guess what? I'm going to take now the prime and connect all my primes. Alright. Actually, you know what? Now I kind of feel like Doritos. You know what I'm talking about? Oh my goodness. Some Cooler Ranch. Alright, so do you notice that with a scale factor of 2, the triangle doubles in size? It is actually going to hold more area than just double, but it's doubling in size. So guess what? If it was a scale factor of 1/2, it's going to actually shrink that puppy down, right? Woo! Okay, everything's going to be cut in half. Alright, here's another one. I just don't have time for this for the video. A 1/2, it's going to shrink. Ladies and gentlemen, you're going to cut everything in 1/2. So 1/2 of -4 is -2, correct? Ah, that's bad. That's real bad. Alright, I'm not going to do the process on this. We're just going to kick it out. 1/2 of -4 is -2. 1/2 of 4 is 2. Okay, 1/2 of -4 is -2. 1/2 of -4 is -2. 1/2 of 4 is 2. Man, there's a lot of stuff here. 1/2 of 4 is 2. 1/2 of 4 is 2. 1/2 of -4 is -2. And then you plot both, and you can see the scale factor of 1/2 is actually going to be half as small. Have fun doing that, guys. I'm not going to do it. We only have, we're halfway there. Alright, here's how you find the scale factor. Alright, so here's the formula for scale factor. It's your new over your original. Okay, so your new points divided by the original point. Okay, so for instance, okay, find the scale factor. If this is my original, okay, so let's take this. Alright, this is an original. Okay, I'm an original, baby. Okay, and here's my new. Alright, that matches up side by side, right? Alright, these are located in the same spot. I take my new, which is 6, divide it by my original, which is 15. And what would you say? What is that? 6 over 15. Is that an enlargement? Or would it be a shrink? Or what do we call that? Not enlargement. It's enlargement or reduction. There we go. Ooh, I like that word, reduction. So, well, 6 over 15 actually simplifies. 3 goes into that. 3 goes into 6 2 times. 3 goes into 15 5 times. So the scale factor is actually going to be 2/5, which is going to be a reduction. It's a fraction. Reduction fraction. Alright, one more. Find the scale factor of the two similar figures. So, the scale factor here, I'm going to take my original, and it doesn't matter which one I take. So, why don't we take this bad boy here. Alright. And here's my new in that same location. Now, judging by the size difference, it looks to me like this is going to be an enlargement, going from 6 to 7.2. So I'm going to say, alright, remember, new 7.2 divided by the old, which is 6. Okay? And if you do that, I'm going to move the decimal over twice, and I've got 72 over 60, just because I don't like decimals and fractions. 72 over 60, let me see, that is 1 and 12 out of 60s. Let me 12. That's actually 1 1/5, I believe. I'm going to keep it coming down here. 1 1/5. Perfect. Okay, or 6/5. If you want to say 6/5, I think 6/5 also work. Now this is all done, no calculator, as I always brag. So it looks pretty good, guys. There's your dilation scale factor. Remember, new over original. I don't know why I'm looking in the mic here. Hey guys, come on. No. Alright. So, new over original. How can we remember that? New over the original. Are new things always over original things? New things are always better? They've upped the ante over the original? So new is always on top? I don't know. Try and think of something. You've got a homework assessment here that you guys need to do here. Under the dilation of a scale factor 2 with the center at the origin. 6 and 7, what will it be? Alright, we have a scale factor of 2, so we are bumping everything up by 2. So S prime should equal, if we're bumping everything up by 2, well, 6 times 2 is 12. 7 times 2 is 14. And boom. You guys smell what the rock is cooking? Or is that too young for you? Alright, number 2. Let's just do that quick and then we'll be done because we got done a little early today. What is the scale factor of the dilation with the center of that? If point E is here and point E prime is there. Okay, now which one's the new one? Remember, Optimus Prime is actually the new one. So, I'm going to take the new, because new is always better, right? I'm going to take 15, divide it by 5, because that's the old. Now remember, I'm sticking with my x's here. You're not going to want to mix your x and your y's up. That's silly talk. Okay, I could if I wanted to. Alright, what's 15 over 5? We're going to do it both ways here. 15 over 5 is 3. The scale factor to number 2 should be 3. Let's see, though. What if I would have taken the y's? Alright, what if I would have taken the y's here? And y's are always a pain in the neck for me to write out with the mouse. So I take my new, which is 9, all over my other y, which is 3, and that's my oldie. What a goodie. An oldie but a goodie. 9 divided by 3 is 3. It doesn't matter which one I grab. You're still going to always get the same scale factor. Now, finding scale factors is very important. So work through the rest of this. See if you can find the scale factors. Identify any dilations, all that kind of jazzy stuff. And, well, have fun. Have a good morning. Bye.